Ladies and gentlemen, hello, and welcome back once again to the Inside Analysis Big Data Ecosystem Market Overview. My name is Rebecca Joswick. I'm Senior Editor and Analyst with the Bloor Group, and today I've got Phil Mercurio of SQLstream giving a demo of their technology. Phil, take it away.
Okay, thank you very much. Well, as Damien mentioned a moment ago, what we're focusing on in Streamlab is being able to process unstructured data and get it into SQLstream, and also get some visualization out, get it into S-Server, excuse me. So the data I'm going to look at is coming from the USGS earthquake site. This is the URL that I'm reading from. It's an atom feed, and each entry looks like this, one entry indicating one earthquake. It's the all the earthquakes in the last hour across the world. And the fields that I want to pull out are going to be this ID field, the title. I'll get the date and time from this updated field, and I'll get the location of the earthquake from this point here. So I'm going to grab this URL and go into Streamlab, which is a web application, and start out by creating a new project, which we'll call Quakes. Streamlab starts out with some online help pages. You can dismiss those here, but bring them back with this icon. The other thing going on in this upper corner here is this icon that indicates the goals for the entire project. In some ways, you're filling out a large, complicated form with a lot of assistance from the system itself. But this index, the list of goals, points to all the different pages that need to be filled in, and what needs to be filled in on those pages. And each of these arrows will take you to one of those pages, or you can browse through it from the top. This dialog also shows you the SQL script that's generated so far. It's blank right now because we haven't done anything in the application yet. But you aren't forced to look at the SQL, but can see it at any time. So we are trying to make sure the user can coordinate their actions with the SQL that's generated from those actions. At the top level, the data that we're trying to get from the user to help build their application starts out with the sources of their data, and then we'll go into the guides that actively process the data. We have a number of sources set up. We can read from a local log file. We can read from streams or tables that are already set up in S-Server. Today, I'll use the web feed. I'll take that URL and paste it in here. This is an atom feed, so I'll select that here. And I'm going to shorten the sleep interval. It's currently every 60 seconds. I want to go every 5 seconds, so we'll see updates more frequently. The data is not changing that quickly, but we want to see it update quickly. And then down here, I can start specifying what fields I want to pull out of that block of atom data that's being sent. For each item, I just specify the title, the column name, in this case title, and then the XPath, which is a way to reference something inside a piece of XML for that location. And if it doesn't have a prefix in front of it, like this one, where it has GORSS, if it doesn't have a prefix already, we have to use default NS, default namespace. So this is all we need to do to parse that feed. We can sample, the last thing I'm doing here is telling you that this when field is a timestamp, so we'll convert that as we come in. We can sample data for, there's something wrong here. Let's see. I think it's usually this guy. There we go. Let's see what the error is here. Okay. forgot to create the schema. That's the problem. There we go. So this is a sample of the data. What we're looking at here is the output from S-Server itself. So this verifies that this has been configured properly and that S-Server has what it needs to read that source. Now we'll go in here to the guide and create a new guide. And select that output as the input to this. In this interface, we're looking at two ends of the pipeline, the input and the output of the pipeline. Currently they're the same because we're not doing any processing. This is the script of operations that will be built up in the lower left-hand corner here. Up at the top, we have various operations, various commands that can be executed. We can fill in the parameters to them. And there are a few different groups of commands here. And then here we have suggestions. All of the commands that are in the current group can propose one or more suggestions for operations that should be added to the script. And as we get better and better at the rule-based AI here, the suggestions get more and more relevant. So to the point where often the right suggestion is right up here at the top or near the top. So looking at the data, first of all, we have this where field here. We can see these pop-ups showing us what data has been collected about each of the different columns. Here, this is already a timestamp. The where column is recognizing as something that could be split in one or two different ways. You can split it on dashes, or you can split it with spaces. In each case, it will generate two columns. So if we select that column, then those suggestions should come up to the top of the list, and here they are. We want to split on the spaces, so we'll do that. Okay. The other thing we want out of here is the magnitude. Magnitude is not actually available as a separate field in that feed. Kind of would think it would be, but it isn't. But it is here in this title. So we can go here, and using the extract operation, we can just actually just highlight the text we want to pull out, and that'll fill this in for us. So it's going to extract from title, starting here for 3 characters, and we'll call the resulting column magnitude. Okay, we'll take that. Okay. Now, the back-end server that's feeding this application is watching the data go by. That's part of the suggestion mechanism here. It knows what's in the data, not just what's in the database itself. So for example, these 3 columns are all strings that are 1024s. They're all text, but it's recognizing that the contents are numbers. So it's putting them in the category number. It's highlighting them in a green outline here to indicate that they're a recognized type. So if we focus our suggestions by selecting the cast operation, we'll see that one of the things cast wants to recommend is that we cast these 3 values, these 3 columns, as doubles. So we'll accept that. And now we've got our data in a more reasonable format. Everything is in fact numerical. These are now double values. So we're actually ready to go straight to a dashboard with this. I'll pick the custom dashboard map and table. Now, the first thing we need to fill in are the latitude and longitude. Which column is the latitude and which column is the longitude? again, the back end is actually watching the data. So if you look here at the pop-up for where 1, it's saying that it contains latitudes, longitudes, and bearings. It's looking at the range of the data and recognizing that it could be any of those types of values. But here, the range of this column, it doesn't include latitudes. Latitudes between -90 and +90 degrees. So what this is saying is the values here are outside of that range. So this is probably the longitude column, and this is probably the latitude column. So we'll take that guess. We'll take where 1 is the lat, where 2 is the longitude. The value we'll get from the magnitude. We don't need the key for this, but the ID that identifies each individual earthquake, because we are getting repeated data here, we'll keep on reading the same data over and over again. We'll put that in that field and add that to the list. Now, each item in the script here, notice the script itself forms a sort of textual provenance of what's happened to the data. You could read this almost like a recipe for what has been done to the data to get it to the output. Each of these items has an icon that can bring up a dashboard. This icon indicates that it's a custom dashboard that's been modified for a particular purpose. So we'll go ahead and bring that up. This dashboard has 2 panels, one showing the data coming in and one showing a map. I'll show some of the dashboard fields here, properties here by selecting a different map type. This is a pan and zoom map. And I'll set some of the options here. Let's let it collect 200 events. I want to draw circles around each earthquake. So I'll take the value and multiply it by 20 to get the diameter of the circle. I'll have it show only the most recent event, so that it'll only show 1 event for each ID. And I'm going to change the label here into something that's more interesting. We'll put the title here in the label. Okay. Wow, there's a lot of earthquakes. So it's clustering the events, and every time this happens, there are earthquakes in California. Okay, I'm here. There's an earthquake. Oops, I mistyped that. Okay, so there's a 1.8 east of me here. There's some other small earthquakes, nothing really big, thankfully. But you can see we've gone from unstructured data, well, or at least data we didn't know the structure of right away, to an interactive map in just a few clicks. Now, this is an actual standalone application, so I can save the dashboard, and then I'm going to grab the URL and close it. And then I'll save my Streamlab application. And before I go out of this, I'm going to actually show you the SQL that's generated. This is the SQL we generated today to process the data and get it ready for that map. I'll then take that URL and paste it in here. So Streamlab isn't even running anymore. Everything is in S-Server, but it's still running, right where we left off, as a matter of fact. And there we go. That's my demo. If you have any questions, I'll happily take them. Anybody still there?
I am. Robin?
Okay.
So one of the things...
Go ahead.
We have an echo on the line. So why don't you ask your question, please?
See if I can handle this muting. I'll ask a question. So in terms of sharing, would this be that URL, for example? I mean, obviously it can be embedded somewhere, but would somebody have to be running sServer to view that at all, or could you email that to somebody and they can just open it up and see it?
Well, it is talking to sServer. It's actually getting the data in real time. So we have an application called the Web Agent that provides a gateway between sServer and web applications. So you'd have to have that set up on a machine that the application can get to, and that the other end can talk to sServer. But yeah, after that, all you need is the dashboard server to get it running, and you can go to that URL and it'll run. But it is exposing, the insides of sServer. This is actually live access to the database.
I have a question that Damien mentioned it in his presentation. It's about the continuous ETL. We have been struggling with ETL from the beginning of databases, and now you do it continuously? You do it at the source? How does that happen?
So do you want me to take that one? So we have a variety of adapters and agents that will collect information from various sources and forms, from files, from databases, from message buses, from sensors, from TCP/IP and UDP/IP. I think we have about 80 in total. And so what they will do is they'll generate data. The most crude form will be just a record, a payload, which will be either binary or text. And if there's a timestamp that comes with it, that will be there as well. If there is no timestamp, we can add one. The server will add that timestamp, so you'll basically come through at the worst level, you're going to have a payload and a timestamp. Streamlab can just take even just the basic payloads and allow you to explore those payloads to be able to basically, through a number of iterations, pull out all of the structure. You start off with that one payload, which means a single column. And then as you look at it and work out how to chop it up, you may chop it up based on, for example, common separation, or pull out fixed format fields. You may parse it using XML, whatever you want to do to split it up into sub-columns, and then you'll rinse and repeat, go through each of those, and you'll tease out the structure for each of those columns. And you're doing this all the time while the data are flowing and are available. You have input streams, you're generating output streams, and at any point in time, you can go back and take a different path if you feel you've gone down a blind alley, or in fact, you've made a wrong choice. And to check to see whether what you're doing is correct, you can of course visualize the results. You can eyeball the value of the data, or you can have it generate dashboards to see what it looks like. So that's how we sort of explore and change the data. Using the full power of SQLstream Blaze, you can enrich the data or validate it using a whole range, the full power of SQL to, for example, aggregate, filter, deduplicate. Deduplicating is as simple as a select distinct over some time period of some time window. And you may want to enrich it or enhance it with external data, so join it with external data from databases. And so as the data flow along through these pipelines, they start off maybe as a single sets of raw payloads, and as they flow along the process continuously, they get refined, they get split up into multiple fields. You select the fields that you want, you combine them with other streams, and you get any number of streams of valuable information, which at the end are used to update external systems or keep databases and data warehouses updated. Does that make sense?
Right. It's just amazing how the world has changed in 20 years. That is just fascinating stuff.
Yeah, the amazing thing is you can even be doing your applications and your graphs whilst the data are running, whilst the applications are running, and changing it all. It's a bit like servicing the engines on an aircraft whilst you're flying.
That's a nice idea. I have a question which is just, it's a usage question more than anything else. Quite clearly you look at this technology and you think, oh, this is all about real-time streams, analyzing them and getting actionable intelligence from them, maybe passing them to human beings, or even injecting them into various applications so decisions are enacted automatically. But do you have, in terms of the users of this, do you have people who are also using this in conjunction with Hadoop and in conjunction with, very large data warehouses? Is it always a kind of real-time thing, or is it, because you do have this extremely powerful parallelization capability that I'm sure could be used elsewhere?
Absolutely. So in terms of, there are a number of different use cases with Hadoop. So the first thing that I think is worth recognizing is that Hadoop is a stream storage platform. It stores sequences of data. It does allow you to access them in random order or in blocks, but it's basically a stream storage platform because it stores streams and you can extend and append to those streams. So it's a great source of streams to come into SQLstream for testing or just to analyzing as the data are coming in. It's a great place to store the results from SQLstream. And then using something like HBase, it also is an appropriate way, it's also an appropriate mechanism to enhance and enrich those streams. Another use case, though, entirely is to, for example, you want to, very often when you're doing continuous real-time processing and want to take actions, you obviously have to know what the actions are going to be. We're querying into the future continuously rather than querying on demand randomly into the past. So you have to know, what you're looking for and what the processing is that you want to do. So you'll want to do some analysis on your historical data. For example, say you want to decide, I want to serve up ads based on the real-time contextual behavior of someone using on the internet right now, or a promotion based on what they're doing right now and what they're purchasing. To do those, you want to obviously analyze a lot of data in the past to see what would be good hints, what would be good, what is the profile of someone that you want to serve up a certain kind of advertisement, what kinds of things should they be doing, and what do they end up buying. And so you can run those analyses, and you can store lots of historical data and stream them then through a number of different scenarios, SQL streaming queries, with different kind of profiling rules, and then score the results. So because we're able to process and work with the embedded timestamps and to restream, then you can use Hadoop as a way of then, if you like, generating large numbers of these jobs to do this analysis and process these streams maybe in 100 or 1,000 different scenarios. So and then once you get the one that comes out best, you then actually deploy that on the live streaming data. Another use case is actually populating Hadoop. We believe we are currently the fastest way of getting data in and out of Hadoop. And the reason that is the case is that Hadoop is fundamentally a Java-based architecture. And within our processing, we wanted to support Java as a first-class language, but even all of our execution is being done in optimized C++ for performance reasons. So we had to deal with the problem of how to get data from Java into the outside world in C++ very efficiently, and also how to deal with very efficient data representations and protocols on the wire. So as a byproduct of doing that, it turns out that we're also now the fastest way of getting data in and out of Hadoop because we have this very efficient interfaces to our stream processing platforms. And why is that important? Well, if you want to now get data into Hadoop from large numbers of sources and want to continually update your Hadoop platforms, we can do that and give you real-time insights into the data at the same time. And that allows you to not only do real-time cleaning and aggregation so that when the data hits Hadoop, it's already cleaned, but you get an idea of what's going on. You can have other applications that are being triggered as the data are flowing. And then we are generating probably a lot of output information that's going into Hadoop, which will still then be very valuable and useful for you then to be able to do your batch-based analysis, your machine learning analytics, and run those on Hadoop too. So there's a sort of a variety of use cases that hopefully make sense that I just sort of streamed out in a row.
Yeah, it certainly makes a lot of sense to me, especially I guess in the situation where you're in the what we're now calling the Internet of Things world, but where you're being deluged by a whole series of events. Just actually getting them into Hadoop, if you want to, in one way or another, process them reasonably swiftly. I suppose ingest is a big deal.
Yes, I think we're talking about huge volumes of data, potentially growing. Continue to grow exponentially and growing very, very quickly. With Internet of Things particularly, you don't necessarily always as well want to store each and every single record, and you get a lot of noise coming in. You get repeated records, and so yeah, you can put all the raw data into Hadoop and crunch it down and try to reduce some of that noise, and that might be one way of going. But it's also possible that you are able to do that on the fly now using stream processing, so that you recognize those duplicates, you recognize the redundancy, and you're removing some of the noise and increasing the signal of the stuff that's flowing out from the sensor networks. So you're already starting off giving yourself a bit more of an unfair advantage and reducing by an order of magnitude the noise that's coming into the system, and storing a whole bunch of noise may not be the best thing. Particularly if you want to take action on it, of course, it's really important.
Yeah, it's true, isn't it? One of the things about Hadoop is it's a great place to store a lot of things. It's quite true, but it's actually inconvenient to delete things from there. It's not, well, it depends how you're using it, of course, but if you've got 3 copies of everything, if you actually want to take information away, it's probably better if you never used it to never put it in there in the first place.
Yeah, it's very true.
Well, that's all that I had to ask. Has anybody else got any questions?
No, I think that about wraps it up. And thanks so much to Phil Mercurio and Damian Black of SQLstream. Fascinating demo about how easily and quickly a lovely and functional dashboard can be built using SQLstream. Thanks so much, guys.
Thank you.